Hello, this is Mrs. Correa at John Marshall High School, and today we're talking about how to find the area of circles. So before we start finding the area, let's just talk about a circle. So a circle has many specific parts, including the radius, R-A-D-I-U-S. The radius, which is often referred to as just the letter R, is the distance from the center of the circle to the outside edge. Now let's label that part of the circle here on our diagram. So that's from the center to the edge, and that is the radius. I'm going to label that with an R. We also have the diameter, is a straight line that passes through the center of the circle, and it has two endpoints on the circle. So that means that is a line from one edge of the circle to the other edge of the circle, and it passes through the center. And we're going to label that line D for diameter. So your radius is halfway across the circle, and your diameter is all the way across the circle. Our last part of the circle that we need to talk about is the circumference. Circumference, and we use the letter C to represent the circumference, and is the distance around a circle. It is all the way around the edge of a circle. We'll label that C for circumference. It's also kind of a fancy word for the perimeter of a circle, but because it's a circle, we use circumference. Okay, so now that we've labeled all three parts of our circle, let's investigate finding the area of a circle. So in this situation, Professor Smart is teaching her students how the formula for the area of a circle was derived. That means where the formula came from. She cuts a circle into equal pieces and rearranges them below. So she took her circle and she cut it into equal pieces, just like a pizza. And then she broke it apart and she arranged it in this line here to create a new shape. So part A asks, what general 2D figure do you see when the pieces are rearranged? What is the formula for the area of that shape? So when you look at the shape she created here, kind of ignoring the fact that this got these little curves, we're just going to see this as a straight line. What shape do you see? I'm kind of draw in my lines here. We've talked about this shape already. It is a type of quadrilateral. It is a parallelogram. And the formula for the parallelogram is area equals base times height. So if that's the case, when I look at my parallelogram, my base is going to be this distance here, and my height is going to be this distance here, which is the radius of the circle from one edge, from the center of the circle to the edge of the circle is going to be the radius. Now, when I look at this in comparison to the circle, this is 1/2 of the circumference. This distance here is. And then from the center of the circle to the edge of the circle, that is the radius. Okay, so while the formula for my parallelogram is base times height, because I'm talking about a circle, I'm going to replace my B with the 1/2 C times R, okay? Now I know that my formula for circumference is 2 times pi times R. So I'm just going to replace the C with my formula for circumference. And if you do 1/2 times 2, you just get 1. 2 divided by 2 is just 1. So these cancel each other out, and I'm left with a pi times r, and that gives me my final formula of pi r squared. Okay, so my formula for the area of a circle is area equals pi r squared. We'll talk more about that as we go along, but let's look at part B to this situation here. Based on the diagram above, how is the circumference of the circle related to the length of the parallelogram? Well, we already answered that question. The length of the base of the parallelogram is equal to half the circumference. Remember, because that was this half of the circle is right there. All right, and then that's how we created our formula for area equals pi r squared, which means pi times the radius again. All right, let's see what this looks like when you're actually finding the area of a circle. So moving down here, it says using the diameter and radii, which is plural for radius, given below, find the area of the circles. So circle 1, it wants our formula, and our formula is area equals pi r squared. And we're going to start by plugging in the values for the radius. And so they told us that the radius equals 3. So I'm going to rewrite my formula, and I'm going to say, I'm going to keep my symbol for pi, but instead of r, I'm going to use the number 3. Okay, now we're going to simplify that because 3 squared is actually the same thing as 3 times 3. So 3 times 3 is 9, so I'm going to rewrite this as 9 times pi. So if I do 9 times pi, I find the area of a circle. Now, do you remember what the value of pi is? Remember, pi equals, I'm going to put it up here in our little notes up here. Pi equals 3.14, okay? So if pi equals 3.14, then I'm going to multiply my 9 times 3.14, okay? And that's going to give me my area. So that's going to give me 28.26. So the area of my circle is 28.26. Now don't forget the label, inches squared. That's our final answer for circle 1. Let's look at circle 2. So in circle 2, they gave us a measurement, and this is the measurement of the circle all the way across, right? From one endpoint to the other endpoint with the center in the middle. So that's actually the diameter. And in order to find the area of a circle, we need the radius. So we don't need the whole distance, we need half the distance. So we're going to do, sorry about that. We're going to do our diameter divided by 2 to get our radius equals 5. All right, so same formula, area equals pi r squared. I'm going to plug in some values. Instead of r, we're going to use 5. So I've got pi times 5 squared. And we're going to simplify. We're going to write this in terms of pi. So that means we're going to go ahead and multiply that 5 times 5. So we get 25 pi. Now 25 pi means multiplying 25 times 3.14, right? And that's going to give me 78.5. So the area of circle 2 is 78.5 centimeters squared. squared. All right, I'm going to let you do circle 3 on your own. I am going to jump to the back of the page and get you started on this question. I want to make sure that we don't get intimidated by these word problems here. So this problem says, number 5, 2 different trees are being planted in an outdoor garden. Each tree requires a specific amount of space for the roots to grow. How much more space will tree 2 require? Okay, so whenever you're tackling a word problem, you kind of have to translate what the words are telling you. So what do we know? Well, they also gave us some pictures, right? So we know dimensions for tree 1 and tree 2. Okay, now we know that the diameter of tree 1 is 16. So the radius has to be half that. So 16 divided by 2 is 8. All right, I'm going to write 16 divided by 2. So we remember that's what we did to get our radius. All right, now tree 2, they already gave us the radius. Okay, the radius halfway across the circle we know is 9. Okay, so this is what we know about the situation. So what do we need to know? Well, we need to know how many more square feet will tree 2 require? So how many more square feet in circle 2 than circle 1? All right, so let's come up with a plan. In order to solve this, we're going to have to find the area of both trees, right? And then once we find the area of both trees, we have to subtract. We're going to find the difference. So just to kind of give you a plan, and then I'll let you try it, okay? We're going to end up doing the area of tree 2 minus the area of tree 1. And that's going to give us our final answer. Now, so go ahead and find the area of tree 1, the area of tree 2, and then you're going to subtract to find your final solution. So I'll let you finish that from there. Make sure you show all of your work on the rest of this, and let me know if you have any questions. Thanks for listening.